All right, so Monday and Tuesday, guys, we dealt with square roots, perfect squares, cube roots, and perfect cubes. We're going to continue dealing with square roots of really single terms, which we're going to talk about what those are. But they're going to be called square roots with variables, okay? We're going to have variables inside the square root. Now, anytime that we've been dealing with variables, you guys remember our exponent rules? Our exponent rules basically dealt with what? Variables and exponents. So it's going to be the same concept here. When we're dealing with these, they're going to be put into a form, guys, where we have our radical, the radicand, or basically a number or a value that goes there, and m is my exponent. Okay? Now, square roots with variables are also known as monomial square roots. If I asked you guys what's the prefix of monomial? Mono, and what does that represent? 1. So this is basically one term, okay? This is one group, one set of numbers, variables, one monomial, okay? It's all grouped together as one. Now, just like numbers, variables can be simplified. We looked at that with our exponent rules, okay? Now, like I told you earlier, guys, it's going to be given to you in this form. The square root of a and m as my exponent, okay? Now, so once again, just like we already know, guys, just like numbers, variables can be simplified as well. If we are given in this form here, it says if m is a multiple of 2, which means it's going to be what type of number? Anybody know? It's going to be an even number. All even numbers are multiples of 2. Okay? If it is a multiple of 2, we're going to use this rule, this formula. Okay? It's going to be the square root of our radicand, which is a, and m, our exponent, is going to be divided by 2. It's going to be split in half. Okay? If it's not a multiple of 2, which means it's going to be what type of number? It's going to be an odd number. We're going to break it apart, okay? Now, and you also might hear me use this term. I may say split it because I'm going to use that term quite often. Instead of break, we're just going to split them, okay? And now, this formula, it says the square root of a with our exponent m is equal to the square root of a m minus 1 times a. Now, essentially what I'm going to show you is going to be this, but I'm going to put it into a little bit simpler terms for you just to make it a little bit easier, okay? Now, we had talked about the square root of 4 would be 2 times 2, right? You've got to have the same thing multiplied by itself to give you that perfect square. Just like 9, 3 times 3, those two values, same values, multiplied by each other to give you 9. Are there any two values that you could think of that are the same that you could get x squared with when you simplified this, if you were to take the square root? So simply, it would be x to the first times x to the first. Okay, those would be the two values. So if we were going to take the square root of this, it would simply be x to the first. That would be the square root. Okay, now that goes back to our product rule, because remember, our product rule tells us to do what with our exponents? Add them. Okay, so here we're simply going to do this by splitting it in half. So here, guys, if you're looking, x squared, 2 is my m. We're going to end up dividing it by 2, which is going to tell us that the square root of x squared is simply going to be just x, or x to the first. Okay? All right, same thing here, m to the 6th. M to the 6th. If we split that, what would the square root of m to the 6th be? M to the 3rd. Okay, now I'm going to pause right here. Now, looking here at number 3, guys, we've got a value, a coefficient that's going with our variable and our exponent. Okay, ask yourself the question, can we take the square root of 9? Yes, what's the square root of 9? It's a perfect square. You've got your cards, you know. So it's going to be 3. And then can we take the square root of k squared? It's simply going to be what? Okay. All right, moving over to number 4 very quickly. Ask yourself, can we take the square root of 64? Yes, square root of 64 is 8. Square root of p to the 4th is, it's going to be p to the 2nd. Good. Okay. Now, if you're looking at 7, this is one of those where we talked about it's the second part of this. If it's even, we can simply divide it by 2 because it's a multiple. Okay? Now, if we're looking here, y to the 5th is an odd number. This is where we're going to split it into 2 pieces. Okay? We're gonna do the same thing here like if it was a non-perfect square root or if it was a non-perfect cube root. Now, earlier when it was talking about the rule of the formula subtract 1, we're going to take one of these y's away. So we're simply going to have y to the 4th, the square root of y to the 4th, times the square root of y to the 1st. Now, what we've been studying in the previous weeks, guys, with our exponent rules, you guys should know that y to the 4th times y to the 1 is the same thing as what? Y to the 5th. Would y'all agree that those are the same thing or the same value? Okay. Now, this is where we were talking about we split it into 2 groups. Now, the 2 groups that we split it into are, one group is we can take the square root of it, and the other group is we cannot take the square root of it. So here, if you're looking, can we take the square root of y to the 4th? Yep, it's simply going to be y what? Y squared. Now, everything that we cannot take the square root of simply comes right down here below it, and we end up with y to the 1, or simply just y. Now, looking here at number 9, guys, there's always a question that I tell you to ask yourself. You're going to ask yourself if you can split each value, or not really split each value, but can I take the square root of each value? Okay, so looking here, can I take the square root of x squared? Yes. Can I take the square root of y to the 3rd? No, it's got to be split. So right now, I would simply just go ahead and draw your 2 square roots. That right there tells you, and you can put your multiplication sign in the middle. It really doesn't matter at this point, because what can't be solved is just going to come straight down with it. Now, you have a column that we can solve and a column that we cannot solve. So x squared, we said we could take the square root of it, so it's going to go in the column of yes. Y to the 3rd, we have to split it like we talked about. So we're going to take one of those away. So it's going to be y to the 1 is going to go in this column, and what's going to go in the solve column? Y to the 2. Okay, now we're going to go z to the 4th, and z to the 4th is going to go in the solve column. Okay, so now we have one column that we can take the square root of, then we've got a column that we cannot take the square root of. Okay, all right, so square root of x squared is x. Square root of y squared is y. Square root of z to the 4th is z squared. And then all of this is multiplied by the square root of 1. All right, so back to asking yourself that question. Can you take the square root of 81? Yes. Can we take the square root of r to the 7th? No, because it's got an odd exponent. So go ahead. Like I told you, go ahead and draw your 2 square roots. And then we'll go from there. All right, so back to 81. 81 is going to go in the column of yes, I could take the square root of it. R to the 7th, it's got to be split. That's where it was talking about earlier. If you guys missed that, where it was talking about subtracting 1, we're simply just taking 1 away from that r to the 7th. So it's going to be r to the 6th and r to the 1. Okay? S to the 4th, we can take the square root of it, so it'll go in the solve column. All right. Now, simply take the square root of the 81, the r, and the s. Square root of 81 is 9. Square root of r to the 6th is r to the 3rd. And s to the 2nd times the square root of r to the 1, or simply just r. All right, now we're going to skip down to 15, guys. All right, ask yourself the question, 68, is it a perfect square? It's not a perfect square, so we know we're going to have to break it or split it into 2 square roots. Okay, what perfect square will go into 68? Is 34 a perfect square? Remember, it's got to come from our perfect square list, so we can take the square root of it. What? 4? What else? Is there another one? Or is it 4 times what? 4 times what? 17. All right, so we have 4. That's under the column that we can take the square root of. And then 17, because those two multiply together to give us 68. Okay? And then 17. Now, come to our variable, p to the 3rd. Can you take the square root of p to the 3rd? No. This is another one where it's going to have to split and go into both columns. So here, we're going to have p squared and p, or p to the 1. I like to put the 1, even though it's not mathematically correct, but I can see and visualize that I know that it's a 1. Okay? So then you've got 17p to the 1 in the column that we can't solve. Okay? Now simply come back and let's take the square root of everything that we can. The square root of 4 is 2. And the square root of p squared is p. And then we simply have everything else right here, 17p, or p to the 1, whichever one that you. All right, now let's go to 17. 27, is it a perfect square? No. So we're going to go ahead right now and split it. It's a perfect cube, but it's not a perfect square. All right, so what 2 numbers are we going to split it into? 9 and, oh, sorry. 9 and 3. All right, now, looking at just the x. There's no number up there as far as the exponent goes, but can you split x to the 1st? No, we cannot take the square root of it, so it by itself has to go over here in the column for the column that we cannot solve. Okay? Then we come y to the 16th. We know it's an even exponent, so we'll put it in the column that we can solve for. All right? Now, let's simply take the square root of what we can. The square root of 9 is 3. The square root of y to the 16th is y to the 8. Good. And then we simply bring down everything else that we don't have, which is 3x.